Okay, so right, to make this delay coil, I didn't want to be fatted about winding wires and then making a slider adjustment toggle switch to basically jump between windings, because the problem with that is the windings, yeah, that it's, if I just did one layer of windings on a small piece of plastic, then I've got to attach that to a service, and then I've got to basically have a rotary system where I can toggle, and wires tend to move around. So I decided I was going to do it on a circuit board, so I could actually have a coil in series with this, and then use this part to adjust my tap-in points. So, but there's a problem because these tracks, this coil is so tiny, and the coil's got to be very thin so I can get some attenuation. Otherwise, I won't get enough attenuation. But these tracks are extremely thin, and the problem with that is that the toner, when I do the toner transfer to make the PCB, sometimes you get a tiny dot missing, and we're talking about these tracks, these little lines here. If you want to know how wide they are, they're literally about 0.3 of a millimeter. So if I get a knife blade, right, this is a knife blade here, and if we go really close, you'll see that the actual thickness of the blade is wider than the actual track. So yeah, these are very small, and I've had to touch them up with some dabs of ink to repair them. Now I was thinking, how can I repair these tiny fracture lines, because there are some very tiny fracture lines in the track. Normally they're insignificant, because when you have a thick track, you can have a bit missing and it's still okay, because the copper goes around the part that's missing. But because these tracks are so thin, the smallest amount of error can cause a break in the track. So I decided, so anyway, I'm going to do them smaller. So I've just laminated this one here. So the idea is quite simple. I'm going to use some acetone to basically melt the toner a little bit, so that it melts together and doesn't create a break. So instead of having tiny little fractures, because it's going to be acetone, a small amount of gas actually, I'm not going to use liquid, because it runs, it leaks, and then it smudges. So what we're going to do, what I thought I'd record doing actually, this should have cooled down now. So what I'm going to do is I'm going to put this in my little chamber, right, and we're going to basically give it acetone treatment to see if we can basically loosen up the toner to the point where it all stays on the copper. And obviously once that the paper will basically go transparent, and I'll be able to look through the paper to actually see. Let me just try and get this up here. Oh, actually, maybe I should prop this up on something. Just give me a minute. I'll just seal my box again, because there's some gas in there and it stinks. Right, so where's my camera stand? Alright, I'll just stick this camera in here a minute. I don't want to block the camera view. So here's the thing that I'm just gonna take the tape off first of all. Right, I don't know if you can see what I'm doing. Oh, actually I need to put the other light on. It would help. Right, so just as I used the gas acetone vapor in the chamber to subtle up the 3D prints and to make the fibers bond together, this should also work on this. I'm just going to take the tape off so the acetone can get into the paper effectively. I'm not going to take the paper off yet. I don't know if this is actually showing up. I think it is. So, but I want to make abilities for these switches, these delay lines. Right, so I've taken the tape off. Now this one I did earlier, it's got loads of errors on it, so I'm just going to put that one aside for now because I'm going to try this method as well. And if this one works better, then I'll redo the other one. Otherwise, I might still use that one. I have been touching up some of the cracks. So what I'm going to do now is I'm going to get my acetone chamber. And I'm going to pop this in here. I think I'm going to try and put it at an angle so I can see what's going on. Right, we'll leave it at an angle. It's probably going to fall down at some point. Well, hopefully it won't. Now I'm going to get some acetone on this tissue paper, so I'm going to soak this with acetone now. Right, I'm going to put it on the top, and the gas should soften up the toner and the paper should become transparent, and we should be able to see, because there's no plastic in there to absorb the acetone gas, it will literally have nowhere to go. So it should, I'm going to put this light directly on the container, it should start to make the paper go transparent after a few minutes, and we should be able to see the transfers show up, is the hope. So yeah, this is a time where I could have done to use time lapse, I suppose. But anyway, if it doesn't show up, I'll just add some more acetone to the tissue paper in there, because we want it to basically saturate the paper, but we don't want the toner to run. Now, I might have to make this lay flat. I might have to tap it and lay this board flat inside the container, because I don't want the toner to run. I don't want it to start smudging and running downwards horizontally, because it will ruin everything. I think we're okay for the moment because it's not transparent, but once this paper becomes transparent because of the acetone vapor, actually I can start seeing the toner coming through the paper now, I think. Actually, my syringe run out. I didn't really have enough to put in there, so I'm just gonna top my syringe up and put a little bit more on there, because it's happening too slowly by the looks of it. So this is an idea which I wanted to try out, because it seems to work well with ABS plastic. I need to lift my light up again. Oh, what have I done? I keep knocking my mouse. Well, I don't think I've got enough in there. I'm just going to soak this tissue a bit more. Right, that's pretty saturated now. If that's not enough, I don't know what will be. Right, I've sealed the container. Now let's just watch, because I have to keep an eye out to make sure that when it goes transparent, it means it's got all the way through the paper. Let's lead it backward a bit. It's resting on that little plastic nub that's at the bottom of the bit of the container. It's holding the circuit board vertical so it doesn't slide. But I don't want it to go flat yet, because otherwise you won't be able to see very well. And I'm trying to record it on video. So I'll bring the light down. Right. We're just going to wait and see what happens. I know one thing for sure. If I spray that acetone directly onto the paper, it does go transparent. So it should go transparent, even in a vapor container. It's just a question of how long. How long will it take? And I want it to be even. That's the reason I'm not spraying it on, because one of the problems with spraying it on is you always end up with areas where you put too much and areas where you don't put enough. So what happens is you get smudges. Some areas it's smudged, and other areas where it hasn't had enough. So this is why I'm using the gas method, because the gas is even, and it will take time, longer period of time, and it will be more even as the gas basically swirls, the acetone gas vapor basically swirls around inside that airtight container. It will do a much more even job. Now if I notice that the bottom is getting more saturated than the top, then I'm going to have to lay this board down. I'll just tap it and it'll fall flat. So how long is it going to take? I've never done this before with a circuit board, so I have no idea how long it's going to take. It depends on that paper, how long it takes for that paper to saturate. Um, and I just want to loosen the toner. I don't use water and soap. I'll tell you why, because them lines, those little lines, normally what you do is you put the circuit board in some hot water and some soapy hot water, and you rub it until the paper all comes off. But those lines are so thin, they're so fragile, I'll literally destroy them. They'll just come off the board and there'll be big holes and chunks missing. So that's the reason why I'm not going to use the hot water and soap method, because this board, the copper, actually seems quite thick really compared to the previous other circuit boards. There's quite a thick layer of copper there, but that's why I've had to use thin lines. So yes, this is why I'm going to do it this way, because it's not invasive. It doesn't put any brute force onto the copper or the toner. It's very, very gentle, and this circuit board transfer paper basically has a thin film of plastic on one side, which makes it easier for the toner to transfer onto the copper. And that thin piece of plastic is what needs to be permeated with acetone to make it release the toner onto the copper. And that is the reason why I want to do it this way, because it will be more effective if I do it over a slow period of time. And I've got all the time in the world really to watch this and see if it works. And I know for a fact that if I can't see through the paper, it's definitely not soaked the paper. So yeah. But maybe I need to lay it flat, because I'm noticing the bottom of the paper seems to be peeling a bit and the top isn't. So yeah, I'm going to have to lay this flat, so I'm going to tap it. Right, it's flat now. Actually, you can probably still see it. Right, that's good. So I've laid it flat more or less. Yeah, we can actually I can actually see that the bottom nearest the camera is actually a little bit more transparent than the other end. But I've laid it flat now, so yeah, I don't have to worry too much about it. Most of the vapour's heavy, you see, it goes to the bottom of the container, so the bottom of the container will have more acetone vapour in it than the top, because it's a heavy gas and it's heavier than air, so it will sink to the bottom of the container. Now, knowing that, it means that I really need it to be lower like that. And I can't, there's no room in the container to move the circuit board anymore flatter, so I'm going to have to prop it up with something. So I'm just going to stick some sellotape underneath here. That'll work. So that's almost vertical, almost horizontal now. So I'm just basically, can I turn that light out? Not really. I'm just going to leave it and wait and see what happens. See if this works better. And I know that tissue paper in there is saturated right now, so it's got nowhere else to go. So it's not going to be absorbed by any plastic, because there is no plastic in there. The only thing that is really in there that can absorb it is the paper itself. Possibly the fiberglass board, but I hope it doesn't damage the fiberglass. It should be alright. But the copper definitely won't absorb it. So, but I am starting to notice it seems to be more transparent than it was when I started. So yes, it's definitely starting to permeate that paper now, and it's a slow process, and that's what I want. I want it to be slow, because I want to be really, really gentle on it. Then I should be able to lift that paper off without any effort whatsoever. It should just literally lift straight off, leaving all the toner on the board. And the acetone will also make it stick better to the board as well, is the idea I've got. And I've done a lot of talking and there's not a lot happening right now, so yeah, I tell you what, there's no point in really stretching this out. So what I'll do is I'll kill the stream right now, and I'll basically just do an update later, and I'll post a picture over the top of this video to show the result. But you're not probably won't see much anyway. I'll just do an update video later on, because this could take an hour. I don't know how long it's going to take. It looks like it's going to take a long time by the looks of it. So right, because I'm not seeing a lot going on right now. So, well, we'll be back later. Bye for now.